Bismillahirrahmanirrahim. Today we shall talk about rotations. If you recall before, we talked about transformations being of four types: translations, reflections, rotations, and dilations. We have talked about translations, which are also known as slides or glides. We talked about reflections. We talked about reflection about the x-axis, y-axis, and about any particular line, such as y equals x. Today, inshallah, we shall talk about rotation. When we talk about rotation, what we're saying is we take a figure and kind of rotate it in the plane, and that's different than reflection or translations. For example, if I have a point A over here, and you can reflect a point, you can reflect a segment, you can reflect a triangle, a quadrilateral, you can reflect anything. So we're going to start out with a point. So when we talk about a rotation, we have to talk about two very important concepts. One is that you always have to have a center of rotation. In other words, you're always rotating something about something, center of rotation. Okay? And even if, for example, if you have a clock that's hanging, right? If you have a clock that's on the wall, the hand clock and the minute clock, the minute and the hour clock, they're rotating, right? But they're rotating about the center of the clock like that, right? So they're always rotating about the center. So that's the same idea. You always rotate an object about some other point, which is called the center. It doesn't have to be the origin. It's a very convenient point to rotate across, but it could be any other point. Nevertheless, when we talk about rotations, one important concept is you have to always understand there's always a point about which you're rotating, and that point is called the center of rotation. The second thing that we have to appreciate about the rotation is that you're always rotating a certain degrees of rotation. So you can rotate 10 degrees, 15 degrees, 90 degrees, 120 degrees, or 270 degrees for that matter. So you can rotate any amount. And so we have to know how much we are rotating, and that's called the angle of rotation. So you have to know R-O-T-A-T-I-O-N, rotation. So when we talk about rotations, you have to know the center of rotation, about which point you're rotating, and you have to know the angle of rotation, how much you're rotating. Now, you can rotate clockwise, or you can rotate counterclockwise, and that both are fine. But in mathematics, we tend to rotate counterclockwise, like Sunnah style. So you can rotate clockwise or counterclockwise, but unless otherwise stated, it says rotate the image 120 degrees, it implies rotate the image counterclockwise 120 degrees. Okay, so that's very important to appreciate. So unless otherwise stated, we're going to rotate images counterclockwise. It's just by convention. It doesn't have to be there. It's always best to be precise anyway. I think if you're asking questions, rotate clockwise or counterclockwise. Nevertheless, so rotations, you have to know the center of rotation and the angle of rotation. So in Cartesian plane, of course, it's most convenient to rotate objects about the origin. So let's say if we have point A over here, and if I wanted to rotate this point, let's say 30 degrees counterclockwise this way. Now, I'm not reflecting it across the y-axis. I'm not reflecting across the x-axis. I'm not moving it this way or this way. I'm not translating it. I'm not reflecting. I'm rotating it, okay? So to do that, you have to say, okay, what's the reference point? Well, the reference point is about the origin. So if you rotate about origin, means you're doing this. So you connect the center origin to the object that you're rotating. And so that acts as one of the base of the angles. So if you recall, every angle has two sides to it, right? Like this. So every angle has two sides. This particular side, this is called the initial side, or the stationary side, like the initial side. And this one here, the one that ends up being, that's called the terminal side. Terminal mean ending, terminal side, okay? So every angle has like initial, the stationary side, and it has a terminal side. So when we are rotating an object like point A over here, so you connect the point over here, the center of rotation to the object of rotation, and this acts as the initial side of the angle. And then you construct the terminal side. That is, you construct a 30-degree angle starting over here. I'm just going to guess this, okay? I'm going to guess this to be a 30-degree angle over here. That's 30 degrees. And then you rotate the point A over here with the same distance. So whatever this distance is, that has to be the same distance over here. So you rotate point A the same distance, and that would be the new image or image over here. So this would be the pre-image, and the rotated image would be A prime, and you have rotated it 30 degrees. So you angle of rotation and the distance has to be the same. So you move the entire object in that angle, maintaining the same length, the distance between the center of the rotation and object. So the distance between the center of the rotation and the object, that has to remain constant. Okay, so the distance between the center of the rotation object has to remain the constant. So you're just moving the object in a certain angle. Now, as I suggested, you don't have to move about the origin. You can move about any other point. So let's say we wanted to move this particular triangle with the center of rotation being this point K. So as I said, you can rotate about any particular point, and it doesn't have to be the origin. So we're going to rotate this triangle about the point K over here. Okay. So if you wanted to rotate this about point K, what you would have to do is you rotate each of the individual vertex, and then connect the vertices. So you rotate point A, rotate point B, rotate point C, and then you create the image that way. So the first thing you do is you take the center of rotation and connect it to the point that you're rotating, the object you're rotating, and then that acts as the initial side of the angle of rotation. And then you construct an angle over here using a protractor. So I'm going to guess that this is going to be 140 degrees. I'm just guessing that this is 140 degrees, and this would be like A prime over here. So that's going to be the rotated image A prime. So I'm just guessing that this is 140 degrees. Now, the very important thing to appreciate over here is that this distance has to be maintained. So if you rotate 140 degrees, the distance between the center of rotation and the point of the center of rotation and the point that you're rotating has to be maintained. And then in the same way, you can rotate point B. So if you rotate point B, you have to maintain this distance, and you have to rotate it 140 degrees here. So if you rotate this by 140 degrees, point B would be like somewhere over here. Okay, I'm guessing this is 140. You have to forgive me if I'm like terribly wrong over here. So this is going to be point B for me. All right, so that's going to be B prime, rotated 140 degrees, and I'm guessing that seems slightly inaccurate, but that's okay. And then the same thing with point C. I'm going to rotate this 140 degrees. So if I do this, point C, I'm guessing it's going to end up being like somewhere over here, and that's going to be C prime. And this distance has to be equal to this distance. And when I've done that, I can construct a new triangle A and B and C like this. So this new triangle is this particular triangle rotated 140 degrees. All right. So my original triangle was over here, and I rotate the whole triangle about the center over here like this. Now again, how did I do that? I took one point and connected it to the center of rotation and made a new angle, the angle of rotation, and this point was rotated that many degrees. So that's the idea of rotation. Now if you observe over here, now this does not look like a reflection, this does not look like a translation, it's a rotation. The whole thing is being rotated like a car going around a curve, right? So this is the idea of rotating an image across a particular point of rotation. So you can rotate about any particular point. It doesn't have to be the origin, but using the Cartesian plane is precisely useful because we can kind of fix the center of rotation to the origin. And then we can move objects, whether it be points, across the Cartesian plane much more easier. Now, although you can rotate about any particular points, we tend to rotate 90 degrees, 90 degrees, 180 degrees, 270 degrees. In other words, we tend to rotate by 90 degrees. So the rule is very simple. Let's say if I have a point over here, this is going to be like point 2 and 1. This is being 2 over here, and this is being 2 over here. So whenever you rotate 90 degrees, so if I were to draw this particular segment here, if you were to rotate this 90 degrees, okay, this is going to end up being like right over here, okay? So that's a 90-degree rotation. And this ordered pair here, it's going to be -1 and 2, okay? So, and then we can rotate 90 degrees. So you notice something that happens. For two things that happen with the ordered pair when you rotate 90 degrees. So whenever you rotate 90 degrees, first thing you notice that the x and y, they switch their spots. So 1 went over here and 2 went over here, right? And the second thing that happened is that one of them changed the signs, right? So now this is what happens. Whenever you rotate, this you can remember this rule. So for every 90-degree rotation, rotations, this is what happens, okay? So you take the original point, all right? So this is the original point, let's say is x and y, okay? There are two things that you do, all right? First thing that you do is you take the y and you negate the y. You make it a -y, okay? And the second thing you do is you put that in the place of x, okay? So the y becomes -y like this, and it goes into place of x, and then you take the x and put it in place of y like this. That's for every 90-degree rotation. So if you want to do a 90-degree rotation, we're talking of as counterclockwise, because that's kind of like how we do it, right? But that's like our habit, rotating counterclockwise. For every 90-degree rotation, you first, there's like a two-step process. You take the ordered pair that's y, and you negate it and put it in place of x, and then the x will go in the place of y. So let's say if I have a point over here, I'm just going to give a point example. Let's 3 and 4. And if I want to do a 90-degree counterclockwise rotation, so two things I do. I take this and make it negative and put it in the place of x. And then the x will go in the place of y. So if I rotate this point, that's 3 and 4, if I rotate it 90 degrees, it will become -4 and 3 like there. So that's a 90 degrees rotation of this point. And you can do another 90-degree rotation of this one, okay? But for example, I'll give you another point before we do that. Let's say if I give you a point over here in the second quadrant, that's -2 and 3. If you wanted to rotate this point 90 degrees counterclockwise, again, you do two things. You take this, you make it a negative, and then put it in place of x. So that becomes -3. And then you take the x simply and put it in the place of y like that. So if you rotate that 90 degrees, it'll become this. You can take this point and rotate it again 90 degrees. If you do a 90-degree rotation over there, for this one, again counterclockwise, you take this one and you make negative of it, so that becomes +2, all right? And then you take the x and you put it in the place of y like this. There, ta-da! So that's a negative rotation. So two negatives will give you a 180 degrees. So if you want to do 180 degrees, it's like rotating 90 degrees and then rotating again 90 degrees, right? So you do two of these. Okay, that's pretty easy. Now, if you want to do 270 degrees, that's like rotating 90 and then the 90 and then 90, right? It's like doing this rotation 3 times. So it's pretty easy to rotate 90 degrees if you remember this particular rule. Anytime you rotate 90 degrees, this is the rule that you follow. You first take the ordered pair that's y, and you make it a negative and put it in place of x, and then the x will switch in the place of the y. And if you keep doing that, you can do it if you do it twice, 180 degrees. If you do it 3 times, it's 270 degrees. And then if you do it 4 times, it's like 360. You're back to where you were going. So it's very easy to rotate these in the Cartesian plane like this. Inshallah, we shall elaborate on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.